Testing, testing, testing. Hi there, guys. My name is Rohan Beve, and today we are going to be talking about the Big Whack Theory. Today we're going to be talking about what is the Big Whack Theory. So, what is it? So, around 4.5 billion years ago, okay, Earth mostly looked like a ball of hot crust, okay? And then one day, okay, this big space rock, okay, which was this about the size of Mars, comes crashing into Earth at the speed of 9 kilometers per second, okay? So it crashes in, and then boom, okay? Now the Earth just is covered with molten lava, okay? Seas of lava. And some of the debris, okay, slowly falls out and starts moving around, okay? This was known as the Big Whack Theory, when a rock whacked into Earth, okay? And it not only just created some debris that eventually turned into the moon, and not only that, but might also have literally whacked the Earth itself to the side of it. And we're still dealing with these effects of this big whack. Okay, so we know our Earth, okay, like everything else in the universe, okay, is constantly rotating, okay? And since it's constantly rotating, that means there must be a point of access. But unlike what we think it's straight, in reality, it's actually tilted a bit. It's normally tilted around 23.5 degrees, okay? Tilted. Now, this tilt is called the Earth's obliquity, okay? And I can't pronounce it properly, but I'm just going to call it Earth's tilt. And the thing is, okay, every now and then the tilt slightly changes over time now and then, but the moon mainly keeps it stable, okay? So you might think this slight tilt, okay, it might not sound that big. It's just a slight tilt. What could possibly be so big about it? Well, it has many significant effects. Okay? For example, it's the reason why we even have seasons to begin with. For example, let's say we have a paper and a flashlight, and we put the paper on a wall, okay? We shine our flashlight on it, okay? We see that the light hits one spot of the paper, right? Now let's say we take the paper and slant it to a degree, okay? And we shine the flashlight. Guess what happens? The light spreads more out onto the paper. And that's basically what happens with the tilting and why it's so important with the seasons, because due to this tilt, it stays that way in space, okay? So let's say it moves here, okay? And that means it's summertime, right? Because the northern point, okay, the northern part is facing towards the sun, which means it's taking in more hot side, okay? It's basically taking in more sunlight, hence it's summertime. And then when it moves to the other side where there's less sunlight, it becomes winter, okay? So this tilt basically also changes from time to time, okay? So every like scientists have proven every uh 4,000 years, okay, every now and then, every 41,000 years, the Earth slightly tilts a little. It wobbles between this balance of 22.1 degrees and 24.5 degrees, okay? And it constantly wobbles in between those two. And the thing is, okay, these slight changes, okay, have long-term climate changes. Okay, so for example, if it's tilted to 24.5 degrees, that means the seasons are going to be more extreme. while if it's tilted to 22.1 degrees, the climates are going to be more extreme. Okay, so, and because of these more extreme climates, there would be more of an ice age, right? Every now and then in this balance, and then the seasons are more extreme, there's going to be more sunlight, more heat, and all that stuff happens. Okay, but what if it was straight? Well, many things could go wrong. Okay, now there are many possibilities, many things can happen. Okay, for one thing, there will be no seasons. One possibility that could happen is an eternal ice age. Okay, since even just a slight degree change, okay, slight angle change, can cause an ice age. Imagine if it was fully straight, right? It could cause an entire eternal ice age, and the surface of the earth would be covered in ice, and there would be like no sunlight. Well, there would be sunlight, but it wouldn't melt all of that fully. Okay, so the earth would be forever encapsulated with ice. Okay, so that's one outcome. There are still many other things, and we actually don't know what would happen if the earth was actually tilted straight. But all we need to know is that we should be thankful that that big space rock uh, bonked or whacked the earth and tilted it. Okay? So that's basically what the big whack theory is, and that's basically it. Thank you for watching this video, and hope to see you next time.